Hey, all right, look, there I am. It's me, John Park, and this is John Park's Workshop. Welcome, I welcome you all. Thanks for tuning in today. I've got a great show in store, I promise. I wouldn't just say that. Let's see, checking in on Discord. If you're not in Discord, go to Discord. It's where all the chat's happening. Of course, we also do have some chat over in YouTube. You know, you can pick either one. I watch both of them. That's true. Hey, Adabot is in the YouTube chat. So there you go. Some people pick one, some people pick another, some people are in both, right? A little sip of coffee here. It's a hot one today, but I've got the AC turned off because I'm insane. Why do I have, I don't know why I have it. You know what, it bugs me, the noise bugs me. I know you guys don't hear it, but it freaks me out. I feel like I have to shout the whole time. So, okay, good. We've got a level check from C. Grover. Voice sound is -6 dB. Average, -2 dB. Peak, good. That's excellent. So let's see. First of all, I want to talk briefly about the music that I opened with today. I have been building up a modular synthesizer, and in part of building up the modular synthesizer, I've been using a virtual modular synthesizer, of which I am greatly ashamed, but that was from VCV Rack, which is a free, possibly open source, not sure, virtual modular synthesizer that I wanted to check out. I think that was using a Turing machine. Yeah, that's right. Turing machine is a module that generates random and semi-random notes, which you can put through a quantizer. It also has an expander that outputs random or semi-random drum beats, and you can tune how random and how much it locks in on patterns. So anyway, that was all built there. Anyway, that was the music. I gave it a name. What did I call it? Joy Quercus. There you go. Check it out. Oh yeah, Yannick, love my Disney cup. Thank you. This is Disney Toon Studios, a animation studio I worked for 5 years at. In fact, my shirt today is from one of the movies we worked on, which is a movie called Planes from the Cars world. If you're familiar with Pixar's Cars, Planes and Planes 2, or Planes Fire and Rescue, are the two that we did there at Disney Toon Studios. And I'm very sorry to say that they have shuttered Disney Toon Studios as of about a month and a half, 2 months ago. I worked on the Tinkerbell movies there too, so that's very fond memories, and for some reason I've got the nostalgia, Disney Toon nostalgia today. All right, so thank you, Bravo Delta. You said you liked Planes. Planes was a fun movie, fun to work on. Thank you, Yannick. All right, so what have we got in store today? First of all, let's jump into this coupon code. Funny Bone will get you 10% off in the store today on anything you throw in your cart. We've got all kinds of great stuff. I'm going to talk about one in particular today, a new one, but also some other products that you'll see that I'm working with here in the project today. You might want to throw those in your cart, and you'll get 10% off on anything except for gift certificates, subscriptions, and software. All the goods, all the stuff. We got lots of great stuff in the Adafruit store, so go check it out. And that coupon is good for today until midnight. Funny Bone. And yeah, one funny bone, not bones. That's right. Are you making, Yanisko, are you making a joke about bones, which is a slang for dollars? I know, I don't know if they use that slang in Finland. You're Finnish, right? We use it here, bones. Yeah, Funny Bone, that'll get you 10% off. Which now brings us to the product of the week. And the product of the week is the brand new Hallowing M0 Express. Look, I've got one right here. This is a early, sort of not quite prototypey one, just about production, and the production ones came out yesterday in the store, so you can go order some, presuming that they're still in stock. Let's see, let me pop this up. Are you in stock? Let me reload. Yeah, there's 61 of them in stock. So that's the Halloween. So The hollow wing is a, well, let me turn mine on. In fact, I've added a little lanyard because one thing this reminds me of is a badge. Check this out. Like on a lanyard, you get your badge if you're going to a convention. I've been jealous because a whole bunch of my friends on have been showing off on Twitter and Instagram their DEF CON badges. Tons and tons of crazy badges. So this makes me feel like I'm part of the fun a little bit. This is the hollow wing, which is a Feather M0 Express based microcontroller that has all kinds of cool goodies on it. You can see it's got this TFT display on it, and I'm running the Phil B Paint Your Dragon eyeball code, which is a very cool use for it. It has the breakouts that you might expect to find on a Feather board so that you can attach a Feather wing, like there. You can see it on the back there. It's also got capacitive touch, 4 capacitive touch pads down here. It has a 3-axis accelerometer built on. It's going to be pretty cool for doing props, costume effects. It has little JST plugs for plugging in NeoPixel strips and a 3-pin sensor. It has the LiPo battery charging circuit and can be run off of LiPo, which is awesome. It has 8 megabytes of flash on there so that you can put a whole bunch of audio files. You can play WAV files directly off the board using CircuitPython. Or you might want to store graphics or animations on there like this eyeball. What else? We've got... what else is on this board? Yeah, it's got an amplifier, so it'll play back, it's got a little speaker output, it'll play back sounds, and what else? There's a 4-pin sensor, actually, that you can use I2C Grove sensor plugs on. I don't have any of those. I gotta go look and see what kind of stuff I can plug in and use. There's a light sensor, and the light sensor is reverse mounted, so it's actually facing out this way, so you could do things like change the dilation of the pupils on the eyeball if you cover the light sensor or vice versa. And then you'll be able to plug in wings to it. I haven't tried that yet, but that is our new hollow wing. So go check it out in the store today. There are 61 of them in stock. Let's see how many of you can buy before the end of the show and get 10% off with our coupon. Remember, what was that coupon code? It was FunnyBone. You can tell we're gearing up for Halloween a little bit here at Adafruit. So hence the hollow wing and my Skull and Bones shirt, or actually Skull and Wrenches shirt. And let's see, what else is going on? Oh yeah, Yanni Turunen says I should get that lens too. There's a nice domed lens in the store. If you check out the guide, there's already a guide out. Lady Ada was working overtime. I don't know when she had time to make a guide, but all of a sudden this guide shows up. So we have a guide, and let's see, I'll bet you if we scroll down, no, let me go to the, let's go back to the hollow wing page. We'll probably have a link to the lens down at the bottom. Oh, you know what? My browser window is small, and I think when it's small, it does not show the extra products. All right, you know what? This is a bonus thing. I'm just going to type in lens. Oh, I'm in Learn. Let's go to Shop. Lens. Convex glass lens with edge. And these are in stock, too. Good. I ordered some yesterday. So you can put that on top of the eye and get a very cool effect that looks more realistic, more eyeball-like, more creepy. Okay, so now it is time to, let me prepare something here. I'm turning on a light so that my little green screen on the table will work. And it is time for, that's right, it's the Make Code Minute. So here we have my Make Code screen, and there, that's what I want to turn the light on, my Circuit Playground Express. So for today's Make Code Minute, what we're going to talk about is using the light sensor that's built right onto the Circuit Playground Express with Make Code. So if you look at my code here, I just have a single loop running. This is the forever loop. And in it, I am setting a variable that I've created called light to be equal to the light level. And if we look on the inputs, is that right? Light level, there you go. Light level is one of the inputs. So this brings in the raw value of the light sensor. And then I have a variable called pixel, which I am using this math function that's called map to remap whatever that light level number is. And I tested my values. I'm getting around 0 to 100 and something from darkish to brightish in this setting. And I'm going to remap those values to 0 to 9. Then I'm going to set my neopixels to be read at whatever number value we're getting from this remapping. So from 0 to 100 goes from 0 to 9 on the pixels, and then I clear that so that we don't leave behind a trail and we move. So it's like a little meter, and if you watch on my side here, as I put my hand in the way, I am darkening the meter, and it's going down to 0 and up to almost 9. I'm actually going to get out a little flashlight. And now you can see as I point that flashlight, I can move the VU meter up and down by measuring and remapping the light sensor value. And that is one way to use the light sensor in Make code on the Circuit Playground Express. All right. I hope I kept that under 2 minutes. I think I may have. We'll see how much editing I've got to do later. Yes, so Yannick asked in the chat, CircuitPython is only available on Express boards, right? Feather M0 Express, but not Feather M0. You can run, that's right, you can run CircuitPython on any of our M0 boards. The Express boards have some added advantages, like being able to use the REPL inside of Mu, so that you can do real-time uploads or run individual lines of code and see the output. Mr. Certainly said that was a short Make Code minute. Oh, good. Maybe I did it in a minute this time. We'll see. So yeah, and I'll give you a little extra. This won't go into the Make Code minute because we're going to run out of time on that one. But I'll give you a little extra insight onto this. So in Make Code, what I'm finding is in some cases we have sort of high-level blocks that take care of a whole bunch of stuff for you, but may or may not be exactly what you're looking for. And then we have some lower-level blocks where you can piece things together. So in the inputs, we can choose on light dark or on light bright, and that is just simply a threshold. And I believe you can set that, what that bright and dark is. Here, this set light threshold to some value, or the dark, or dark or bright to a value. So those are pretty good at having sort of a switch so that a thing happens when it becomes bright or a thing happens when it becomes dark. But this tip that I showed today actually brings in those raw values and allows you to have a varying interaction with the board based on varying the light level. In fact, if I have time, next week I'm going to show you a little bonus thing, which is I started using this little chibi meter, which is awesome. It can be an oscilloscope, it can be a voltage meter, right? I think it will measure volts, and it can be a text output. So I was able to hook it up to Circuit Playground Express using Make Code to send serial commands to this, so I could read the light level values on this little scope, which is pretty awesome. I'm very excited about that, and I'm going to start playing around with that more and maybe do some tips and tricks on that. So, wow, that's what we've got on Make Code now. I think it's time we look at our main event. So I'm going to run over to the workbench. We can hide this Make Code. Goodbye, Make Code. And what are we throwing up in the corner? How about that? Check this out. This is the game of Operation, which you may remember from your youth. Oh my gosh, I'm walking away without my coffee. Let me go get that. You may remember the game of Operation. It had this sort of sad sack guy who was about to be operated on a table, and you had to pull out his body parts carefully, because surgeons need to be careful, and avoid touching the edges of the, lift this up so you can see a little better, the edges of the incisions with your tweezers. Otherwise, you would send the buzzer running and light up his nose red. So let me demo it for you. That's a pretty good view. I'm going to switch that to be the large view, actually. There we go. And what I've done is I've built this into a Adabot cardboard box that we ship stuff in. Oops, I just dumped some pieces out. Let me turn it on. All right, and I'm going to try to carefully reinsert some pieces here for a second. Not too hard. And one more, the LED. I think the LED so far is one of the trickier ones. Let me get you in here. The reason I'm being so careful is if I touch the edges of these incisions with my tweezers, you can see there and you can hear it. You can maybe hear it over my microphone. Oh. Oh, I'm going to restart it. All right. So, oh, there it goes. All right, so bad demo. It was working really well before, and the issue is calibration. So we have a hidden trick up our sleeve. I didn't want to show this right away, so let me try to restart it. So I'm going to restart it and keep my hands away from things because I want it to get a good baseline of capacitive touch calibration. There we go. So we can take something out without touching. That one's easy. Got to make that piece bigger. Ah, I touched it, and I don't know if you saw that, but when I touch it, I'm going to go left-handed on this light bulb here. Ah, you can see I'm sending those neopixels to red, and then I have a custom color depending on which one of these I've touched. The colors will tell you, in this case it's blue for the bulb. I should color code these, I didn't think of that. I might fix that before I do the guide. So this one makes sense to go to purple, and we'll get this green screwdriver out. If I touch that, it goes to green. Oh, that's good. So this is actually a bit more sophisticated than the way the original game worked. The original game was your tweezers were actually tethered to the board, and you were essentially grounding a switch whenever you touched the metal. The metal was one big plate, so there was no differentiation between which of these you'd touch. So I thought this might be a good leaping off point for someone who wants to make a more sophisticated game. For example, maybe you only get one try per slot, and if you beep it, it's going to drop one LED down, one neopixel down, or do some scorekeeping for you. And the reason this is possible is if you look inside, let me remove all of these for a second so I don't lose them. These are just made out of cardboard with paper on top. And I've designed this whole thing to be a printout, so when you, oops, there we go again. When you look at the guide, it's going to give you everything you need, the files and the program, which I programmed in CircuitPython. You could probably do it in MakeCode as well, but I did it in CircuitPython. And what's going on the inside is we have alligator clips running from each of the 7 capacitive touch pads on the Circuit Playground Express to, I've made these little boxes, again, just out of paper. This is like some paper craft. If you look here, this is the cutouts, and you'll fold on the dotted lines, and that'll make these little boxes to store your pieces. And there is a piece of copper tape running to that capacitive touch sensor, and that copper tape lines the exterior of each hole. So we get 7 of these holes, and we have 7 short alligator clips running to the foil. And you can see, let me show you a prototype. I went through a few different designs and ideas on sort of how to assemble this that isn't too time consuming. So one way you can do it is with a large piece of copper tape, spread it across the hole, and then cut the hole, and on the back side you'd run a piece of copper tape there. That's essentially what I came up with in the end, is I'm running strips across, or if you can use this big wide copper tape, we sell both in the store. Here's the more typical narrow stuff. But if you carefully cut a piece of this and cover over a hole and then slit it on the edges and down the middle, you can fold these little flaps down which I found to be a pretty effective way. And then I run an extra, either a thin cut piece of this or a piece of this thinner copper wire underneath to create these little tabs that you can hook your alligator clips onto. So that right there, oh, it's beeping at me. It knows that I touched it. So this works, like I said, pretty well. The tuning that you'll do in the software, you'll see where I've essentially set a threshold. And what our hope is that all of these have roughly the same threshold, which can be tricky because these are all different capacitive length antennas. Pretty close. The holes are pretty close in size, and I'm using the same length alligator clips, but just the weird nature of that capacitance antenna of them running the wires, you don't want them to crisscross if you can avoid it. And then we've also got this battery pack actually makes a difference where it's sitting. So it can be fiddly, but I found it not too hard to tune. However, if you run into a real problem with the tuning, what you can do is take a, let me grab a long alligator jumper. You can take an alligator clip and clip it to the back of your tweezers and run that to ground. And now there's absolutely no question about it triggering. And I found that it works with the same threshold that I had set before. But anyway, the guide will tell you about how to change those, tune those thresholds so that it works well for you. And I think you could have a lot of fun, like I said, creating a little more sophisticated game around it. You could use the buttons as well to do scoring. If one person gets one, they press a button and it adds up pixels along the sides. There's a lot that you can do, and I love that it's all possible just on this one board on the Circuit Playground Express. Let's see, so some other things we can do. Let's look at the software for a second. Let me run back over to the workstation. And again, I'm not going to forget my coffee. But part of the idea when I was talking to Phil and Lamore, I think maybe Lamore came up with the idea of doing this project. And I don't know if she saw it, but I definitely, when I was looking up DIY operation game, which is one of the first things I did, I found there was a really good project that the Maker Camp, the people at Make Magazine did a Maker Camp project a few years ago using the Makey Makey. And that one uses USB to talk to your computer, send keyboard commands to the computer, and then they have a web page set up where you could see which buttons you had touched, which is pretty cool. And also you could do that with a Circuit Playground Express if you want, because it can talk USB. You could also hook it up as a USB MIDI if you wanted to play musical notes on the other side. So let's see, did I set up? Ooh, I didn't. All right, we'll see if I can do this without ruining my audio. I'm gonna create a screen capture of my coding environment. Let's see, I think I have this in Moo. Yeah, let's bring up Moo. All right, yes, you can still hear me, good. So I'm gonna move this over, just get it out of my face a little bit. And let me find the Moo. Where are you, Moo? There you are. Let's make that text big O, big O. That's pretty good, that's pretty big, right? All right, it's big enough that I can see it. Aha, I knew I'd lose my audio, but there, I've brought it back. My alarm didn't go off, so I probably I didn't lose audio for too long. Oh, that's a good point. C. Grover said, I should have it sense if someone turns the box over to dump the parts out. That's brilliant. Yeah, because that's a great way to cheat at operation. I never thought of that. Fiendish, yeah, so if we use the accelerometer, you could tell when the whole box goes upside down. And Toddbot has a very upsetting suggestion, which is make the lights do a heartbeat pattern, dun 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 dun, until you lose the game and then it flatlines, beep, which is sick, and I love it. Excellent. So here we go. Okay, so this is the code that I'm running, briefly, I'll explain what we have going on. I'm importing some libraries, so the board, which is a shortcut to talking to all the ports on the board and the sensors on the board. Time, so that I can do pauses or delays. Touch I/O, that's the library that does the capacitive touch. And then I'm using our high-level Circuit Playground Express library imported here as CPX, just because it makes it very quick and easy and very small amount of code. I can do things like turn on the NeoPixels. Let's see. So then I've got an array that I'm creating, which is all of the pins that my capacitive touch are on. And then a array of arrays so that I can loop through those, or a list of lists. Sorry, I should speak Python. And then I go and instantiate all those pads as capacitive touch pads, or those pins as capacitive touch pads. And then here you can see I've set the threshold. So let's see what I can do. Let's see if I can. No, you know what? I won't be able to do that because I don't have CircuitPython on the board over here. This one has make code UF2. But what I'll tell you is this value, this threshold value, the way I determined it is down here in the code. I have commented out this section, and what this section does is it prints. Let me leave that highlighted for you. It prints the raw value per pad, and then it waits half a second. So it goes through all 7 of them and keeps looping. So I just watched that to see what numbers I was getting when I wasn't touching it, but had it hooked up to the alligator clips and the foil and all that, because it matters. And then when I touched it with the tweezers. So I could see where the big leap was anything below 3,500, I hadn't touched it. Anything like jumping up at 4,000, I think, was where I had. The one thing I'll say, the gotcha in this is that is with the USB cable connected, and this will change the capacitance values versus taking off the USB cable and plugging in the battery. So you may end up having to then sort of blindly fudge it if those values vary too much. In my case, this 3,500 worked with it plugged into USB and with it plugged into the batteries. Okay, and then I've set up some shortcuts for some colors for myself, so I can call them by name later. And I made it a little array of those colors, or a list of those colors. And then this is really, all that's happening is during my main loop, while true, for I in the range of 7, so it goes 0, 1, 2, 3, 4, 5, 6, it applies that number to if touchpad 0, if touchpad 1, and so on, has been touched, has the, or rather, it has a value that is above, what was my 3,500 threshold, then it will print out that it was touched. Again, that's just a debugging thing. You could comment that out if you want. It then fills all the LEDs, NeoPixel LEDs red. It plays this tone for almost a second, and then it fills the colors with the colors associated with that pad. So pad 0 has magenta, pad 1 has violet, and so on. And oh, you can see down here actually, this is the output in the REPL from the last time I ran it, and you can see it's just sitting still values were at most 3,092. So I was pretty safe. Here's where I touched one at 4,000. It jumped up to, and it said that I touched pad 0. So that is how you go about using the touch pads in Circuit Playground on the circuit. Say that again. That is how you use the touch pads in CircuitPython on the Circuit Playground Express if you need to tune those values. It's quite helpful to be able to see them and then tune your application. You could even tune these per pad. If you had like a long run of cable going to one pad and a short one to another, you could go through and have a threshold value for each of them, which could be necessary depending on your application, what you're building. Delicious, delicious coffee. Okay, so we've got just a couple minutes left. Checking out the comments. Thank you, Yanisku. He liked the project. Thank you. Dr. Park is in the house. Terrifying. So, and for anyone who doesn't know it, if you're younger than a certain age, you may not have ever seen the Operation game commercials from the 80s or even 70s. Go look them up on YouTube. They're fun. My turn to operate, and then the mom coming down the stairs says, "Operate!" and flips out. And there's another one where she like immediately wonders where the dog is, thinking that they're doing surgery on the family dog, which is nuts. All right, so let's see. What else I wanted to talk about today? I think that's it. To recap, our product of the week is this lovely Halloween M0 Express. Go check it out in the store. There were 61 of them left a moment ago, so let's see if you guys run out and buy some. And don't forget to use your coupon code FUNNYBONE. That'll get you 10% off. And over in the Discord chat, someone, Mr. Certainly, thank you, has posted a link to one of the 1980s Operation board game commercials. I'm pretty sure the game is still made, and then maybe they've updated. He's probably swallowed a cell phone or something like that at this point. But the one thing that I had forgotten about entirely until I looked at one of these ads was maybe the best one, and it was too late for me to build it in here, but the best one, there was a rubber band stretched across two posts. Maybe that was the funny bone, but you had to, with the tweezers, pull the rubber band off of the posts without touching the sides, which was one of the more challenging ones, I think. So yes, go to the store. Use Funny Bone in the store to get 10% off on your purchase today, and I think that is it. So this is going to be a Learn guide that I will be publishing tomorrow morning. So I got to go finish writing that guide. Go have a great rest of your afternoon or evening, and go make some stuff. Thank you so much for Adafruit Industries. This has been John Park's Workshop. Bye-bye, everyone.